Welcome, folks. This is the August meeting of the St. Louis Linux Users Group. We have an interesting presentation tonight. Our distant friend from Des Moines, Andrew Denner, who is a software wonk extraordinaire during the day and software fanatic doing things like this at nights, is going to tell us about building OCI containers with Buildah. Stan, you want to carry the meeting stuff for a minute, and then we'll turn it over to Andrew.
Let's see, just some slides here. It talks about our meetings. We from 6 to 6:30 arrival time. We like people to test their chat, their microphones and sound and screen sharing, things like that. The last meeting we had a little trouble with one of the presenters. He had trouble sharing his screen, so it's a good time in the first half hour to test it out. We start out at 6:30. We do introductions, announcements, talk about other meetings, archives, a calendar, mailing lists, and call for help if necessary. And at least by 6:45, then we go into the presentation. And it's up to the presenter if he wants to have people allow people to ask questions during the presentation, or to hold them till the end. And after that his portion, further discussion is possible on our mailing lists. And since the meeting is being recorded, we're going to post that up on our archives within a day or so. James Conroy, who's here, he's our chairman. Gary Meyer, usually here, he's not. He usually acts as MC. Host Lee Lambert is introducing our speaker tonight. I do some production with the slides and recording and junk like that. And I've gotten Phil to volunteer to monitor the chat room. And as always, I'd like to say we need someone to help find speakers. Gary can't do it all. He tries, but he's only one. And as much as we'd like a clone, it just doesn't happen. As far as announcements, 5 days from now, the fourth Tuesday is going to be the new Linux meeting. The next meeting after that is usually going to be on the first Thursday, the Slack meeting. Our next STLLUG general meeting is on the second Wednesday of each month. Sean is developing some alternate STLLUG and Linux, St. Louis Linux web pages. And so our website may change in the next month or so. I'd like to call for any other people have an announcement they'd like to make. Going once, going twice, moving right along. Do we have other meetings? And after I mention those, we're going to then do a call for help session. As I mentioned earlier, this meeting is the St. Louis Linux Users Group. 5 days from now, it's the new Linux Users Group. And then on the first Thursday of the month, the Slack meeting. Our main meeting is on the second Wednesday of the month. That's the general STLLUG Unix Linux meetings. This Linux presentation meeting is what we commonly do here. The new Linux meeting is for a beginner workshop. The Slack meeting is a configuration workshop. Those two meetings are pretty free format. We have a presentation archives. Only the general meeting and this meeting recordings are archived, usually available within the next day or so. And that link goes on each of the websites. The links are listed, and you can go directly to that page with the resources presentations archive. We have some mailing list, or we have a calendar. And see if I can share this. I'll try. Control. Yep. Nope, I'm not getting there from here. Or am I?
Give me a second, Stan. I can bring it up if you can't.
Okay, if you would, please.
Resources, calendar.
Anyway, our meetings, our sponsored meetings are represented and highlighted in red on that calendar. Let's see.
There you go.
All right. Okay. Like I said, the red highlights show the meetings that are sponsored by us, and everything else is either in St. Louis and face to face, or even hybrid meetings together. Also, we separately list other open meetings that are across the internet. There's such meetings as the Atlanta Lug is on Sundays, things like that. Okay. Okay, I'd like to go back to me. Let's see if I can do this. Okay, and you care to say anything else about those meetings?
Oh, sorry, I just killed it.
That's okay. So I'm going to go back to the slides real quick for a quick shot at wrong button. There. We have a couple of mailing lists. The announced is very limited traffic, usually just meeting instructions. General discussion list. We'll discuss opinions, questions, reviews. Pretty free, open to everything. We have a steering committee
Hey,
mailing
Stan,
list. Yes, sir.
your slides are not on the screen.
Oh, they're not? What happened? Oh.
Yeah, it looks like your Zoom page is on the screen.
Were you using the right computer?
No. If I was using the correct computer, it would know what to do and it wouldn't even bother listening to me. Huh. It says I'm sharing.
But we see your Zoom screen.
I know. What happened?
You're sharing your Firefox browser, and it's open to Zoom. If you just
Yeah,
switch
I understand that. It's just not doing what I want it to do.
Never does.
computers, they do exactly what
it-
you tell them to do in the most
Well,
destructive
that's
way
the problem.
possible.
That is always the problem. It's it is definitely a problem. Of course, like everything else. How about this one? There you go.
There you go.
All
All right.
right.
We have an announce
you're
list,
back.
a discuss list, and a steering committee list. We also have a sysadmin list, but that's for volunteers that are going to help us do actual work. Okay. So if you have sysadmin questions, you can ask them on the discuss list, and more than likely, that's the best place to ask general questions. Okay. Now, before we go any further, we can go into call for help. Anybody like to talk about the problem they've had this week? Or complain or beg for forgiveness or help? Any problems? Everybody just dying to get to the presentation? Is that it?
I don't have anything nice to say about the thing I've been working on, so I'm not going to say anything.
Okay. So the topics we have here at this meeting are generally focused on Linux or either personal or enterprise. Hopefully they're more advanced, important, profound, significant, blinking lights, that kind of stuff. So, okay, Andrew, do you want people to hold their questions to the end or what?
Feel free to heckle away as much as you'd like. I can't promise that I'll have any answers to the questions, but ask away. I usually tend to be a fairly informal way of running things, so it should be interesting. Let's see, I've got everything all set up here. And if I click here, you should be able to see my slide deck right now.
Not yet.
Nope.
Okay, let me try again here. Oh, I need to actually say, yes, I want to share. It makes a world of difference.
Yay!
Okay, so you guys should be able to see the actual slide deck now.
We do. Thank you.
All right, awesome. So just as an introduction here, we're going to be talking about how to up your containerization game, and we'll do a little bit of a dive. I see it completely trimmed off the part of it here, but we're having a deeper dive into Buildah, a little bit of what it is, and we will even have a little bit of compare and contrast to Docker and Podman as well. And I'll, as Gary had requested, I will make sure to define all these for those who have no idea what I'm talking about. And that's okay, because there's a lot of just random words that we throw into technology here. So first of all, an introduction. I'm Andrew Denner. I'm somehow still the president of the Central Iowa Linux Users Group. We meet the third Wednesday of every month, and we are meeting currently in a hybrid format. Hit up our website at cialug.org for our meeting, and the link to how to get a hold of everything and all of that magic there. And we're your friendly neighbors to the north, if not just a little bit smaller. So yeah, by day, I am a senior scientific software developer for a large North American agricultural company called Corteva. It's the old Pioneer, if you've heard of it. And by night, I still tinker with all things Linux and containerization and all of those things. So first, a little bit of information. So we'll dive into it a little bit deeper here in a minute, of the difference of what is containerization. The easiest answer and the best way that I've found for new people to wrap their minds around it, just think of it as almost like a VM that you're running all of your stuff contained inside of this universe in a bottle. As I'll describe here in a few minutes, it's more complex than that, but you know what, we'll get there. And essentially, it cures that problem that all of us developers have, where we say, well, it runs on my computer. And with this, basically, you pack the whole stuff that needs to be installed around it, and even somewhat a little bit of the operating system, and ship it all as one big unit. And that means that you no longer have to worry about what packages do I have installed on my machine. Do I have a problem where the dev machine has version 2 of something like, just say that we have an old version of the compiler there, or something, one of those big problems like that, because it has everything you need all contained. Really, the containerization really has nothing new in it. It's using things like C groups and other Linuxy things all bundled together in one nice package. Docker, the company, really was the first ones that brought about the Docker project, and it sort of, most things are kind of named after that. But however, in the last few years, they, like many other open source companies, have decided to be a little more stingy about freely passing things around. And so if you're a larger company or stuff like that, there are a lot more strings about running their Windows version of it, and they've limited how much you can get into the Docker Hub to download pre-built containers and all sorts of stuff like that. So the open source community as a whole have sort of started to move away and branch out. You've seen a growth of other things like Kubernetes, which is out of the scope for this presentation, as well as people saying, you know what, I really like Docker. I want to run it on my local machine, but I don't like Docker the people. I'm going to fork it. I'm going to take the bits that I like, and I'm going to take my ball and go play somewhere else. And that's where you see sort of the Red Hat side of things with Podman and Buildah coming in. And we'll dive into those a bit deeper here in a minute. So again, the containerization, you remember that we're talking about encapsulating all of your code, all the stuff that goes along with it, and everything you need is completely independent. So it can run in all places. You have a copy of Linux and you're good to go. And so again, sort of this is going to be diving into what is different between a virtual machine, sort of your host OS is wrapping everything, and a lot more of the actual stuff is in this container and is not shared. And so this tends to be very much a lot heavier, but it also allows you to run different operating systems. So you can have a host that's running Windows, and you can, for whatever reason, run Linux on your VM container, and the two don't mix. It's a slightly more secure for the fact that you're not sharing your kernel. So in the Docker and OCI container world, which we'll define that here in a minute, you have shared host kernel. And so if I want to run a different kernel than my host OS has, I'm out of luck. I really don't have any choice. What I have is what I have. But for the most part, really, that hasn't hurt. I haven't been hindered by that really very often. And at that point, you just have to make some upgrades or upgrade your host, and things are okay. But as you can see, there's a lot less shared, which means it's a lot more nimble, and you can go ahead and cram a lot more containers onto the host OS than what you can with a VM. Hopefully all of that is making sense. But as you can see, Linux, it really Docker and the whole containerization world is using a bunch of stuff that already pre-existed, like namespaces, C groups, networking, all of those sort of things. It's just they did a lot better job of packaging it than some of the earlier projects that started down this path, like chroot and other things like that. Stan, I saw you looked like you had a question, and or Lee.
I always have questions. It doesn't necessarily they make any sense, but the heck. Oh, does it make any difference for the hypervisor? And I see in the representation on the right, does it KVM or VirtualBox or something else? Does that make any major difference?
I mean, it makes a world of difference in performance, because I mean, if you're using like OpenBox or something like that, just in general, it's a lot. It's running in more of a user space area. KVM or vSphere or any of those sort of things, all are perfectly fine. The idea still holds true.
Okay, I see there's a lot of moving parts here, and are you going to be focusing on? I haven't quite assimilated what all is interplaying here. Are we focused on the description on model on the left or on the right, or is it just kind of both?
We're going to be on the model on the left here. This is just helping to explain the difference between, because most fairly novice people think of the untainerization and Docker and all of those things as, well, it's just like a VM. And I was trying to show that no, it uses a lot more of the underlying infrastructure, so it's not quite a VM,
Okay.
but it still helps to think of it in those sort of terms.
Oh, that explanation helps quite a bit understanding what you're presenting here. Thank you.
Yep, and really this is just supposed to be sort of the brief overview before we dive into the deep part here, to catch up anyone who wasn't familiar with these sort of things.
Yeah, and honestly, my focus sometimes drifts.
That's perfectly okay. I'm the same way, and I'm trying to present this, so I get it.
Okay.
And Andrew, back up one sec. One other comment. one of the folks that made a comment earlier, and I'm trying to translate it into something that makes sense to everybody. One of the issues, or not issues, but one of the facets of a standard container is that it has to be written to the APIs provided by the host or by the Linux namespaces or whatever operating environment it's running in. So the question was, how are the containers different? We know if you run them on a Linux machine versus a Windows machine, they have to be built for the APIs available on those hosts. But what about things like Kubernetes or other cloud tools? And I think that's where OCI comes in, but I wanted to make sure that you had that in the back of your mind, Andrew, when you get to those parts of the presentation.
Yep. So basically, to roughly answer that question here quickly, and we can dive into it deeper, the easiest way to think of whenever you hear people talk about OCI containers, they're Docker containers. Just everyone's mad at Docker, so they've sort of walked away from using the name Docker since so many other things use it, even though you still can write Dockerfiles and do that sort of stuff. The OCI is the Open Container Initiative, and it basically is the standard that all of Kubernetes, basically anything that's using the run C world, which we'll dive into here in another chart here in about 2 slides. But anybody who's using that sort of paradigm, it's basically OCI is the group that's the open source big tent that everyone's sharing and collaborating in.
Yeah, and those are all Linux, right? Linux based.
So there is actually Docker that you can run in Windows. If you're using the Linux containers inside of that, you can. They've enabled it so that you can develop mostly for like developers and stuff like that. If your corporate machine has Windows on it, but really under the hood, what's happening is there is a virtual machine that is running Linux, and the Docker in Windows is connected up to that, and it's sending the commands through. And actually, most of the stuff you'll do is running Linux. There are Windows containers as well, and those have to be running on Windows machines. The whole idea, though, is no matter where you're running, your containers all use the host kernel. So the core Ring 0 operating system stuff is shared across all your containers, which is where you get a lot of agility there, but also if that host kernel gets compromised because there was a vulnerability in it, well, now all of your containers lost their isolation essentially, and they have the keys to the kingdom. In Windows, it's using the equivalency of the Windows kernel if you're using a Windows container. Hopefully that makes sense.
Yeah, I think so. And to answer the question that was raised earlier, most normal containers you're running on a Windows machine are actually Linux running on WSL, right?
Yes, running on WSL or the older versions of Docker, they actually spun up a Hyper-V container, which WSL is actually just a Hyper-V container running a virtual machine with a lot of Microsoft special sauce sprinkled over the top of it, so you don't notice.
Cool. All right. Thank you, sir.
Okay, so again, why do we want to do this? It's portable, it's scalable, it's fault tolerant in the fact that, like, say, for example, if you're using some of the bigger technologies like Kubernetes, you can have multiple copies of it. If you burn it down and completely crash it, well, whatever, you kill it. It follows the cattle, not pets idea, where I get really kind of upset if I lose a cow from my herd, but really it's not my pet dog. Where I'm going to get really tore up and really upset if Fido ends up dying. And where also is it useful? It's really useful if you have on-prem processes and you want to move them to the cloud. Basically, it really helps in forklift shifting the whole thing. It's used very heavily in microservices where a lot of these websites you'll see where if you go to Amazon, the deals of the day is one service that the website's loading before it shows it to you. The videos are a whole nother service, the login's another service, and each group of developers are working on just their one little tiny corner of the world. It's really useful in that, as well as portability. Like I said, it solves well, it runs on my computer. It won't run on yours, but it doesn't matter because it essentially is just running inside of a bottle. And here's where we're going to talk into a little bit of those other technology stacks. So Docker, we've already sort of talked about. The Docker company sort of was the first ones that got everything all together. It is an open source project. If you're running in the Linux world, it is still a community edition and is free. It's only if you try to use Docker Desktop where they start charging you a lot of money. Now, of course, it's great if you throw money back at open source projects, so you should, but should and have to are two different answers. So a lot of different things said, this is a really great idea. So Kubernetes, the Run C world, all of those sort of things.
So why is everybody mad at Docker? Before you said everybody was mad at Docker, why is everybody mad at Docker?
So the irritation with Docker is over the years they've started nickeling and diming. They like all things started out first where everything was free. You could buy support, sort of follow the example that a lot of open source projects have gone with. However, they also need to pay their bills, and they started saying, well, if your company's above size X, now you have to pay per seat to run Docker Desktop. They started really clamping down on how many pulls per hour you can use in your pulling down pre-built images and stuff like that from their pre-built Docker Hub, and just sort of have generally started slowly inching that line closer and closer to making it painful enough that you want to buy their service so that you don't have to deal with the workarounds anymore. And so
are you going to cover
that
Docker?
Makes sense?
Yeah, that makes sense. Are you going to cover Docker Desktop, or is that just
Docker Desktop is basically the Windows instance of Docker. So if you want to run Docker on your Windows 11 corporate machine that corporate gives you, and you want to do your development so you can deploy it in the cloud and all that stuff, that sort of whole bundled package that makes everything play nice in Windows is Docker Desktop, or on your Macintosh or stuff like that. And so that particular tool is the one knob that they started cranking down on, where, hey, you're a corporate developer, you need Windows Docker, so and your company makes more than X number of dollars, you're now going to have to pay like $15 per seat, or whatever amount it is at the moment. So that sort of whole thing's left somewhat of a bad taste in people's mouths, and is why, I mean, it's somewhat a little glib saying that everyone's mad at them, but it did sort of touch off this whole, well, fine, I'm going to go do it my own way, as well as like Red Hat decided, hey, we want to be more have more control over how things are built and how things are deployed, and we think we can do a better job, so we're going to build our own thing, which is the Podman sort of space. Kubernetes, basically think of, you have a whole bunch of computers all running a Docker-like thing. and you want to deploy your application into that cluster, multiple copies, you can be flexible, all those sort of things. And that's a whole nother talk diving into the complexities of Kubernetes. But basically, it's you want to run a whole bunch of you want to run stuff on a whole bunch of different computers, and you don't really care which one it's running on, because you're running a whole cluster, if that makes sense.
Sure.
Okay, so to help drive that home a little bit here, you've got this image registry that we were talking about. Docker, the company, is the one that runs most of them, or most of it. However, with the fact that they've been clamping down, yes, that was an AI generated image, and it did have some interesting hallucinations. Those feet are rather terrifying. If you also notice, it's the Turex, which I think it was trying to go for Tux as the name on the side of it. So yeah, it's amazing what you can get when you ask Copilot to generate some images for you. But diving back here into the image registry, basically that's there's a bunch of different images out there that, like, say, Ubuntu or CentOS, or take your pick of Linux distribution, as well as a bunch of different projects. So, like, say I want to run a web server, I can go out and download the Apache container already that's been generated out there, so I don't have to worry about building it. Someone else who's a lot smarter than me has gone out and done it for me. And like I was saying, Docker was the primary folks who were running that sort of thing for the better of the whole community. But unfortunately, bandwidth and disk cost money. So there have been a few different places that have forked out and sort of either mirror it or have their own set of images. Amazon ECR is one of them. They have a lot of public images that you can just download for free. Quay is another one that is basically Red Hat's / IBM's, and you pay the money for it, etc. But the whole idea is that in the Docker world, this Docker daemon runs as root. And that of course brings about a whole nother set of heartburn, because you have to be in that Docker group. All commands are basically running inside of the Docker daemon, which is running as root. So if there's a bug or a flaw in there, and you can pop the Docker daemon, you now have keys to the kingdom. But basically, one of the things that Docker was nice enough to do, they broke out this sort of runtime into container D and run C. And that's a container daemon, which a lot of things can now face. And it obviously they forked and open sourced a bunch of that stuff. And then run C is sort of the containerization running thing that interfaces and connects directly to the kernel and the containers and all that stuff. And it's what Kubernetes uses, it's what Podman uses, it's what everyone basically uses. And that's part of that Open Container Initiative's shared sort of good for the good of all stuff that they host. It's sort of like if you've heard of like Apache and those guys, it's basically running in that same big tent sort of world that Apache does. So there is an alternative, and they later on did come up where you can run rootless Docker, where you still have a daemon running, but it's now running as your individual user, and it's a lot more secure, but that's not the way most of the world runs Docker. So over on the other side, you have Podman, which is completely Docker compatible, or at least should be. There's always edges and there's always dragons at the edges, and you'll probably run into something that will go wrong. at some point if you try hard enough. But then you have the Buildah project, which is for building those container images, which is most of what we're going to be diving into tonight. And then this run C, notice how there's no daemon. You're not necessarily running as root, although you can run it as root just as well as anything else like that. Yes, to Sean's point, Podman, you are traveling the path less traveled, and there are gremlins. But yeah, plus it's Red Hat sort of blessed, so of course there's going to be gremlins with it. But yeah, so anyway, though, like most of the examples that I'm going to run tonight, I'll be running as root because I did something before the meeting here and totally hosed my user account and can't actually run Podman right now with it and Buildah. So yeah, there did something wrong. I didn't sacrifice nearly enough blood to the demo gods. So yeah, it's been fun. But yeah, so anyway, though, Buildah will build your containers. You can run Docker, the Docker files and build them. And Podman actually straight up wholesale stole, well, borrowed its open source. The bits of Buildah that do that, so you can build containers inside Podman as well. Just not nearly as advanced or doing the shell-based stuff that we'll be showing off here. Hopefully that makes sense. So like I said with Podman, it's rootless by default. You can run sudo stuff. There's no daemon, and it's truly free in the fact that no one's charging you money or anything like that. It should be Docker compatible as I get, but of course, yeah, today, but you can do all sorts of really cool stuff with systemd to schedule your containers to run with systemd, kicking them off and run them as services so that if they die, they can be rebooted, all that sort of stuff. They also have a lot of compatibility with Kubernetes. If you're developing in Kubernetes, you can basically use the kube control commands locally, and it will run and generate YAML and understand all those things as well. But again, as Sean pointed out, there are some gremlins with this. Sudo is, so Grant, to clarify here, are you talking about Docker or Podman?
Podman.
So in Podman,
the first bullet on your list.
Yep. So Podman, basically, you do not need to run sudo if you're running as the user. And what that will look like is inside of the container, it will look like it's user or it's root if you're running as root. But any of the files that you have mounted into it or anything like that, you don't have any more permissions than the actual user account that is running Podman. So like say if I decided to mount / into the container, it doesn't matter. I can't go to the Etsy folder and start editing stuff. Where with Docker, if I'm allowed to mount and I'm running as that daemon, I can mount files that I don't have access to as my individual user, but because it's root that's doing it, it has all the keys to the kingdom, so it can do whatever it wants with that file that you mounted into the container. Hopefully that makes sense.
Yeah. It sounds like it's using user namespaces.
Exactly. And it's using the sub user ID sort of stuff, which is one of the hiccups that you will run into depending on how your user accounts are created on the like corporate level. If they don't have your individual machine with the sub user IDs available, you're going to have trouble. But since this is a local laptop and I have full control over it, everything's fine. So we can go ahead and dive into, I see the one slide showing that there was another slide showing that basically Docker is sort of one universe, and the Podman Buildah is the other universe, and that's run by essentially our good friends at Red Hat. But here we can go ahead and dive into some demos here. I'll just go ahead and flip over to my demo machine and okay, use my built-in display. And here we should be able to see some stuff. And like I said, I'm going to have to flip over. Let me make this text just a little bit bigger so that those in the back can see. And basically with, we can cd into demo. And here we are with hello world. Let's just look at some stuff here. Basically, this is just your standard Rust project that we're going to build some executable of and run it inside of a container. So let's go ahead and look at the Docker file. And basically, this is a slightly more advanced version of it, because as you can see, I've got two containers running here. The first one is basically building. It's a Rust Bullseye, so it's a Debian-based container, and we copy the files in the current working directory, which we just saw, into app. Change directories into the app, and then just run cargo build and turn it into an executable. And then from there, we build Ubuntu, or we use the Ubuntu container just because I like Ubuntu. And we copy the hello world executable from the Rust container into root there, basically. And then the default execution is just running that. So if we want to take a look at what is the source code, just to prove that there's nothing going on, it is literally just the hello world example. And if I could type, and I jumped one too far, cd demo hello world. Let's just go so that things will play nice here. Since I broke everything, normally you would not have to do this if you hadn't nerfed your partition and given it, taken away permission or something like that. So now, as you can see, we are running as root. So in theory, if you do get out of it, you do have all of the problems that come with running as root. But let's just go ahead and do pod man. So you could totally just substitute in Docker here and it would run just as fine. Assuming you had Docker installed on your machine. And yes, I can't type and talk at the same time, apparently. And so that should look like any other thing that you've ever seen with the builds. And as you can see, we don't have it local downloaded, which is odd because I know I did have that downloaded earlier today, but apparently either they released a new version of it or something.
Did you have it downloaded?
So we'll have to just,
user, and now you're pulling it down as root?
that very well could be. But here, as you can see, it downloads. And now we're going to build. And it built it. It didn't take long at all. And now we have it running. So then you can do podman run. Just like you would a Docker container, and we name it test. And as you can see, it says hello world. So to answer Sam's question, I'm assuming that you had this installed already just to be for ease of use. If you're running it on Ubuntu or WSL Ubuntu, the easiest way to install Podman would be here if we just go out to and do a Google search for Podman. We just land on the website here, and if we go to their get started page, basically they'll walk you through how to download and install everything, but depending on all the different versions. But as you can see here, all you have to do is just apt install it. The latest version is in all of the repos that matter. So just to prove there's nothing fancy going on here, well, paste. And as you can see, I already have it installed. Hopefully that answers your question, Sam. Buildah works very much the same way when we get to it to install that. If we do a search for Buildah, they actually have, of course, the most terrifying thing. I know they had here, oh, it's on the install page, because you should always trust everything here. As you can see, it does have this option, but there is actually, I believe, a shell script as well. I'm not seeing it. I know this morning I landed on a page that basically you can download a install script from their website, type it into SH, and it just will magically install it no matter what OS you're using. Of course, with that comes the normal warning of do not randomly install stuff from the internet unless you trust the internet. And I think we've all seen enough that you shouldn't trust the internet. So yeah, anyway, though, but I mean, if you can't trust your package maintainers, well, we're probably in a lot bigger problem. But hopefully that makes sense, Sam. But for the most part, the demonstration of Buildah was just to show that it exists and that you can do the building of containers and do all of that stuff, sort of in the interest of time here, since we have more examples and probably more heckling that I hope will be coming at some point here. I can switch back over to our presentation to talk a little more about Buildah. And yes, let's stop. Share screen 1. Okay, and everyone should be able to see the slide deck again. Okay, seeing Stan nodding, we'll just dive boldly forward here. And so Buildah, it actually came before Podman. And the whole idea is that you can create to answer Sam's question, that Docker's on your Windows machine, but not on WSL. If you have Docker installed and you're running Docker Desktop, it should be bundled along. Honestly, unless you really want to jump ship, I'd recommend not trying to mix the two, because I have had some bad experiences sometimes with that. But if you have a VM sitting around, Sam, that would be a great spot to try this. Or like, for example, some of the machines at work I work on are Red Hat machines, so it just made sense to get used to using Podman. But yeah, the issue, Sam, with that is that Docker Desktop at least the modern version of it does use WSL under the hood. And so it makes that connection and runs there. So that's why I said it can be an issue. You can actually possibly spin up a different WSL container, because you can have multiple installs of WSL stuff. We can walk through that here at the end of the night during the questions here.
Yeah.
Oh, well, it might not be installed there. We can totally work through how to do that then. But yeah, so anyway, we'll dive into and troubleshoot that here. But so Buildah. Basically, the idea is that it came before, and the idea is that you can use it to build a working container, basically using an image from a start point, or from just the base nothing. For example, that example of using Rust, you can statically compile Rust so that it will have everything you need, including the Muscle C core libraries, so that basically, instead of having any operating system at all running there, basically you're just running as process 0 your executable. And we'll talk about why would you want to do that, and all of those sort of things as well in a bit. But we'll get into that, like I said. And your images either can be built using, there was a original version of Docker format that was a bit older and slightly different, or the newer modern version that most things are now compatible with. You can build it either way. For the most part, we're just going to go ahead with the default, because that works almost everywhere. And if it doesn't, look up the documentation, because it's a little bit interesting. You can also mount a working container's root file system and make modifications in it just on the command line. You can then unmount it as well, of course, because mounting it without being able to unmount it is just crazy talk. And you can also use all of these changes to make a new image, delete the old images. So you can do all of the CRUD sort of stuff that you'd expect.
What about, so you said you can mount the root file system. What about bind mounts? Can you mount the bind mounts from one container to another?
Yes. So well, bind mounts, what I've done with it, because you're of course using this while you're building stuff, you can do that multi-stage build sort of idea, where you've built an executable in one container. You can essentially copy the files from that other container into the new container. And you can also have multiple containers running, basically mounted at the same time, and move stuff just with copy commands, if that makes sense. Because it just ends up being a happy little folder on your disk system. Hopefully that makes sense. But again, basically, we've talked a little bit about the purpose. And remember that it's using all of the stuff that Docker and others have come before it, that got all contributed up to the Open Container Initiative specifications. And it makes sure, the big benefit of that is it means that all of the other container tools like Docker and Kubernetes and Buildah and Podman can use the containers that it generates. One of the big benefits is that your Buildah does not require a daemon to run, unlike Docker, so it's a lot more lightweight and flexible. It also means that you can spin it up on your CI/CD machine as you're doing like software development. So continuous integration, continuous development it can build your container, you can shell script everything out, and it just will work. And that's why it makes life a little bit easier. You don't have to worry about, okay, is Docker installed on the build machine, all of those sort of things. But so anyway, though, sort of the next step here, we'll dive into the roots and nuts and bolts of everything. So let's go ahead and flip back over to our wonderful Linux machine. And here we are. We have really nothing amazing happening here. I'm just going to flip through my notes here just because they're out of order. Okay, so let's go back to our Hello World example. And the first thing that we totally can do is just run a few commands just to make sure that Buildah is up and running. And so we can do things like Buildah version. As you can see, it's running, and it is built off of that dirty stuff called Go. But whatever, you don't ever have to interact with the code. And that's somewhat just snide remarks that sarcastically Go is, I hate as a language. And yes, I do see that they totally didn't have their clock set right when they built this, because it totally was built at a really, really weird time, which would be 1 second before the epoch. So yeah, not sure what's going on there. But yeah, so that's how you can tell what's around and working there. Thank you for the heckling, James. So Buildah, and so what are other, sorry, it's info. And as you can see, it likes to chuck a whole bunch of JSON at you. But as you can see, some of the underlying stuff, I'm running Ubuntu 24.04. The C groups are version 2. I have a little bit of memory, not insane amounts. It's running that C run runtime. And it's an AMD 64 CPU. I only have 4 CPUs because this is just a really cheap mystery meat Chinese laptop. It's Tigger is the host name. Why, I don't know. It was a good name at the time. And we're running in Linux, and currently we're running as root. I've been up for about an hour now, which I rebooted it before I started this so that hopefully we won't have as many problems. I've got a couple images in the container already. And yeah, fairly easy, nothing overly crazy here. So let's just go ahead and build our container like we did in Podman, just to prove that we still can. So build key. And as you can see, since I'd already built it and it was downloaded, it really just did all of the same things over again. And one thing to call out here is that this is still building just like Docker, where you have multiple stages. Each command in your Docker file is a different layer. We're going to show how you can jump around in that and collapse everything into one layer, which has some pros and cons. We'll talk about that in a minute, though. But as you can see, it's just your bog standard sort of thing. if we want to look at our file and see what happened there, we can do inspect. And we called it test latest. And as you can see, it dumps a whole bunch of JSON to the screen again, but it will tell you everything about this container. And as you can see, there's a lot there. But the big things to remember here is, let's see here, where you can see what C group namespaces options it's using. It's not mounting anything. It's not using the network. It's using a user space and etc. So nothing crazy here. You can see all of the commands that we're running, which again, it's this is some of the stuff that was originally done by the Ubuntu container. You can see it's downloaded all of that and runs all of those sort of things. And as we get down to where it's doing it, we copied in the file hello world, and then the first thing it does is actually runs it. As you can see, it's all in JSON, so it's a little bit messy, but it basically tells you everything that happened here. So one of the things that we can do is let's say that we have a sorry, here flipping through my notes here, and there is the note that I wanted. Apologies, that's what happens when you go through this practice ahead of time. So one of the ideas is that you can use the sort of base, sorry here, flipping through to the right spot. Yeah, that didn't, my slide deck didn't update itself. So yeah, great. Anyway, though, one of the things you can do rather than using the test or your base image, you can let me just do one quick search here because I'm drawing a blank on the name of it. And it is sorry, here pulling a let me quick pull up the name of it here because I apologies here.
Ask ChatGPT.
World. Yeah. Here, that's okay. So let's quick dive in here. Right. Scratch. That was the name because I always think of base, not scratch. But anyway, though, here as you can see, they dive into And if you remember, Go packages everything, including the kitchen sink, so you can get away with it without even doing anything. So we're looking for base. So if we wanted to change Ubuntu latest to the one other thing that we need to do here before we do anything else here while I'm still remembering is as we build it, Cargo doesn't actually, or Rust doesn't actually include all of the C and C++ libraries that it links to. So we need to add basically include the either the GNU C libraries or Muscle, which is a lot lighter version of it. We can do x86_64 dash unknown Linux Muscle, and should work. That should
Want
work.
scratch, not base.
Yeah, scratch. Apologies there. And that works so much better. So now if we wanted to run and it should have. But anyway, though, the point is that you need to package. Oh, I know the problem. The issue is that instead of copying it from target, we need to copy it from a different location because it changes where it's located, just based off of the fact that it's very nice and moves all of your different stuff into different locations. So if you look at target here, you can see that we have this x86-64 Linux Muscle, and that's where it actually is being built. And so if we just go ahead and copy that, and I am failing at clicking. And so then we go ahead and change where it's being copied. Instead of debug, we want to, and we didn't want to copy all of that because that won't be where it's actually at. So we want target on. And I believe it ends up putting it in debug in there. Yes. Okay. So we want target. As you can see here, and as you can see, it just ran and built. And then let's just go ahead and run it in test. And as you can see, it's running. And if we take a look at actually inspecting the image and its test. Now, if we're looking here, you can see that basically all we're doing is copying that file in and it runs. There is nothing else there. And why would we want to do this? It greatly reduces the blast surface or the vulnerability surface, because if you're packaging a full OS and you have everything but the kitchen sink, and you don't actually need stuff like CP, your area of stuff that can go wrong is greatly increased. Also, another thing is that this is as small of a container as you can possibly get away with. No bigger than the executable itself, with everything bundled in with it that it needs for the must-see sort of stuff. And the nice thing there is that you don't have to worry about any vulnerabilities and anything else. And even if they do pop it open and are able to somehow get a hold of stuff inside that container, well, you're still within your container, and the only thing there is the executable itself. So what are they going to do with it? Basically, is the whole idea is lightweight, smaller, it's single purpose, and it just sort of makes life easier. But let's say you already have this being built as an executable on your CI/CD process, and you distribute it around, and you don't want to have to rebuild it just to build a Docker container or anything like that. We can totally move into the more nuts and bolts of Buildah here. And I am going to go ahead and let's just go ahead with this and go Buildah, and we'll pull the container we want to play with. Let's go ahead and use the Alpine container just because it's a nice one to play with. It's small, it's easy, and it's lightweight. So go ahead, we've already pulled it down. We can look and see what we have in our repository as well. And as you can see, I've pulled down Rust, Ubuntu, Alpine. I've got a container called LUG, and a bunch of stuff that I've created that don't have names to them, that just haven't been cleaned up yet. And then as well, the test image that we were talking about before. So let's go ahead and mount Alpine. One of the ways we can do this is let's just name our variable container CTR, and we go container equals $. So we're executing this. The output of that goes into that container variable. And what we can do is, if we look at it, it's Alpine working container 1 is what it magically gets named. Whatever, we just let it handle that. And that's a lot to type, so I like $CTR a lot better. So we want to mount that now. Let's go ahead and build a mount. And since this is Bash, everything that we're doing here can be put into a shell script. But basically all we're doing is saying, hey, go ahead and mount this so it's just a folder. And as you can see, it got mounted into this big long path that is on the overlay, and it's there, and we can start doing things. So now we want to just copy that executable that is the hello world executable, and we're just going to copy it directly in there. So we can do Buildah and copy from, let's see, would be source. Okay, let's build it first just to make sure it's there. cargo build. Going back up my notes here. So build double dash target equals X. Since this is running Muscle x86 underscore 64 dash unknown dash Linux dash musl.
Cargo might not be on root's path, maybe. Maybe it's on your user's path.
That could be. Let's just go ahead and solve that problem. Okay, so then we want to run the same command over again because reasons. And
Is the
apparently,
target x86 64 Linux, unknown Linux muscle, just a text string, or does it actually mean something? Like, is it just convention or actual?
so it means something to cargo because let's just go ahead and misspell it here. It will tell you that it doesn't have that target. So if we do
Okay.
there, you can see all of the different things that you can build it as.
Okay.
And a lot of those probably mean something to somebody, but yeah, but you can do cross compiling with Windows, depending on if you want to use the GNU libraries or the Microsoft version or etc., or even you can compile it for OS X, Apple.
I only compiled the ohos. Sorry about that.
Yeah, there's some interesting ones there, but yes.
Just another demonstration there. Need the SL, but I realized you were just testing us.
There we go. Okay, so it built it just to prove it's here. Let's go back to root. Typing is hard, especially when people are watching. Okay, so here we are in Hello World. We're going to mount that, and then we're going to mount container. There we go. And now we want to copy the files from Buildah into, or from this Hello World into our container. So copy, and a lot of these commands are fairly similar to what you'd use in Docker files. So here we go into target and x86, debug hello world, and we want to put it in hello world. And we want copy, which if I'd read my notes, it would have. And we need to have, sorry, here, where do, oh, yes. So the format is copy, and then our CTR is the name of it. So $CTR. There we go. So it's been copied into there and mounted, and everything is fine. And I believe we can even do stuff like ls lists the containers. Anyway, so now that we've copied those files into there, the next thing we want to do is actually build our image and store it. So what you'll want to do is build a commit.
Yeah, so when you copied that in there, you got that hash back. And so is that like the hash of a layer that was just created when we did that?
Yes.
Wow.
Yep. So that is the hash of a layer that gets created. So it's basically a programmatic bash way of interacting with the same exact thing you do inside of a Docker image or Docker file. So what we can then do is Docker commit container, and let's call it test because we're just using that same container name all over again. We hit control or enter here. And as you can see, it created up the image signatures. And if you look back here, so the end 11, yeah, I'm not sure how that E89F. Yeah, I'm not sure exactly which blob and how the magic gets made here, but as you can see, it ends up getting copied and moved in there. So if we went ahead and looked at our test latest again, you can see that we've copied in the file just as we'd expect. Yep, there's the add. And so if we wanted to go ahead and run it, and we just scroll back up to our Podman, and we wanted to run because we didn't include that command as we did previously. So as you can see, hello world works just as we'd expect it to. So one of the things that I really like for the fact with Buildah is that if you have a let's go ahead and add in that command here. So we can say Buildah config --cmd, and that is going to be our slash hello world again here. And we want to go ahead and add in quotes, otherwise it will not like it.
Is that an L or a pipe?
These are two L's here. That's a closed bracket, and these are slashes. So it's
okay.
Run from root, execute hello world. And we need to tell it which container we want to put this in. So CTR.
I couldn't see that it was a bracket because I had the text bubble was overlaying the top of it.
Sorry there.
Hey, Andrew, if you hit the little minimize bar on the view up here, yeah.
There we go. Sorry about that. Let's see here. I'll get the.
Yeah, this is a very picky command here. It's like you must put it in just the right spot.
There we go. Takes that last. That's one of the minor annoyances that I found with this is consistency is not one of its better things. But so, okay, we just added the command. let's go ahead and add in an environmental variable, because those are always nice to add to. And let's just say ooh, and bar. So that inside the container now there'll be a environment variable foo that is equal to bar. And you can do other things like set the working directory. All those, add your username, or add set what username it is. All the things that you can do in a Docker file, you can still do here. So let's just go ahead and rebuild it. And one of the other things we can do here, and this is what I really like about Buildah, is as you can see, we have multiple different layers. And one of the big issues that you'll always see is some dumb user / developer will go ahead and copy in too many files in as one of the layers, and then will right away go ahead and delete stuff out of it that he doesn't need in the next layer. Well, you're now carrying that boat anchor around of all those big files, or maybe even like usernames and passwords and all sorts of really bad stuff that you shouldn't have in a container that you can see with that inspect command. What we want to do is, one of the things you can do is actually take all these layers and just collapse them down into one layer. And that's beneficial in the fact that you can make for smaller containers, but also if you like to use the Ubuntu base container for all of your work, now instead of one copy of Ubuntu layers, you now have one copy for each of your containers with everything in it, including the Ubuntu container. So it's hit or miss whether or not it's a good idea, but it's nice for the fact that it does simplify things, and it does sort of cure that problem of people doing bad things and having a million line long set of transactions where each layer does have a weight and a complexity added to it, if that makes sense. But what you can do here is the command squash. And we want to take it here. Oops. And as you can see now, if we inspect it, you only have the one container. And so if we go ahead and run it here, there you can see, and so hopefully that makes sense.
Yeah, I
See,
noticed
how
you're
are we
not
doing?
making the hello world executable. Do you have any idea how that's happening?
So the hello world executable, I already had built it on the host machine as with basically the idea that I built it during my CI/CD process as a previous step, and that executable is going to be distributed out to multiple different sources and locations. But we can totally still go ahead with that idea of, I want to build it in a separate container and copy it across. That's actually a great segue, because that's what I'm going to be showing next.
Actually, I meant like the permission to execute that file. Usually when you copy something, you have to make it executable before you can run it. But it seems like you don't have to do that here.
So the one way that I'm getting around that is the fact that I'm putting that /dot there, because that's basically saying, hey, this is an executable, you can run it. But let's just go ahead and take a look at that file just to see what it looks like, just to make sure that we're looking right.
Oh, maybe because you're using Buildah copy instead of the CP command. I'm used to the CP command, which will not, if I'm remembering right, CP does not copy permissions like executable, like the execute bit, but maybe Buildah copy does maintain the execute bit being set, and maybe that's why.
CP doesn't
that might
copy
be.
by default, but you can make it do it.
Yeah. But as you can see, it is an executable already. Any other questions? Long as we're sort of at a pause point here. Okay, hearing none. Let's go ahead and go with that idea of can I do a multiple? Oh,
Can I ask one more? So on your last Podman run, you put the hello world at the end, right? But since we set that command, you shouldn't have to do that, right?
correct. Oh,
I don't know if we committed after setting the command. That's what I was that's partially what I was wondering.
yeah. So we committed.
Oh, you're right. Yeah, we committed right there. But after we squashed, I wonder if I don't know.
Yeah, I'm not sure quite what's happening here. Run.
Well, can't you mount the squashed container and take a look in it and see if hello world is in the root thereof?
Yeah, we can also just hello world is there. So it is there.
But the command is not set. It seems like the command to run that doesn't seem to be set.
Yeah, it does look like. Okay, so we did run command. Wonder, is it because we have our that's the way my notes have it as. Okay.
So you did a commit. Do you also
Yep.
need to do a build? Oh no. So if you
So
commit, you have to do a build.
what I did basically so to go through what I just ran. So I did the config command and changed the quotes around because apparently it's expecting them to be quotes versus single quotes. And that was the big issue. I also added colon latest because just on the off chance that it wasn't getting done, it wasn't copying it correctly. So that's there now. And as we run it, there you can see hello world is being properly installed.
And so if I'm a person who thinks that if I'm a person that thinks, oh, well, I'm just going to look at the Docker file that created this container, and as long as it looks good, then this container must be somewhat safe. You're pretty much proving that's not true with this squash thing, right? Because if you push this up to Docker Hub right now, it would have a bunch of stuff that you've done not being shown in the Docker file that it shows up on docker.io. Is that right?
Yeah, essentially it will show it as it's just one big tarball of gooey goodness.
Okay, so basically any container on Docker Hub or any container registry could have a ton of malicious stuff, and they just squash that layer so you don't know about it, but it could have a ton of malicious stuff in there. And looking at the Docker file doesn't really help you know that or not, right?
Yeah, yeah. So where you sort of as an example here, if you look at the Buildah inspect of Alpine. So as you can see, basically Alpine's history here, the Docker file that went into creating it, essentially they copy in the entire file system into slash, and all of Alpine is right there, everything you need. And then they set the command to run as that you want shell there. So looking at the Docker file, you can see that they've already squashed it into just one container. And you'll see that that happens an awful lot. If we look at Ubuntu and see what they did.
I feel like there's a flag on the play there. Analogous to, I don't see anything that would be qualify as like cryptographic verification. So my concern would be I could create a malicious image that ends up with a, I presume that's a hash name collision and looks like Alpine or Ubuntu or whatever, but it is really my own custom bespoke image masquerading as something that you might trust.
Yeah, so that layer, that is one of the concerns.
And as far as, well, it's a single versus there's multiple, I could repeat that process with the multiple layers. And even if they're the successive layers are basically no ops. But I'm synthetically making history or inspect show things like you might think a legitimate would have with multiple layers and build and avoiding the squash.
Yeah, so my understanding of how the container layers work, you do end up with this file hash, which is a cryptographically secure hash. I forget just exactly what hashing it's using, and that layer, that hash is basically used and can be shared across multiple images. So if you did have a collision, malicious or not, it would cause issues.
Is the file, I understand that the file name is originally generated by taking a hash. However, is there any reason I can't create an image with whatever hash it has, rename that image to another string of bytes that looks like a different hash, and then subsequently include it? And it looks like I'm pulling in a different file.
I believe that both the container repository itself, as well as it's running hashes on things as they come down to validate that it was actually pulled properly.
As you're building it, yes, but I'm talking about if I'm building an image from a malicious Docker file on my system, and once I have created my malicious image and I upload it, and it is a fat image that contains everything and hasn't been squashed, you inspect it and see values like you've highlighted there, thinking, okay, yeah, those all match, that's good, but it's bogus data. Much like I can create TLS certificates where damn near everything matches what somebody else uses, but it is a malicious cert. If you want to get very, very, very dark and deep in the weeds.
Yes. So if I'm understanding right, there's a couple things that will go on there. One, that's assuming that you have access and privileges to be able to upload and clobber my basically my SBOM here essentially that is the list of all the layers that are there, and collaborate with to replace out yours, and also that's assuming that the container repository that you're uploading stuff to is going to let you load that in and doesn't double check your work, which I'm pretty sure they do actually check to make sure that the hashes match. And if you did cook the books and upload and say, hey, this is hash 123, and it wasn't, the moment you download it on the victim's computer, it will say, hey, the hash that I downloaded doesn't match the one that I asked you to send me. So it will throw it out and say it's bad, is my understanding of it. But of course, with all things security, here there be dragons.
Right. And I'm not so much thinking I'm trying to replace yours. It's more the Trojanized freeware of, hey, I have this great new game that seems really like Candyland because it's a copy of Candyland that I've downloaded and I've put a wrapper around or something, and
Yep.
I upload my full image, not the Docker file. And my understanding, which may be wrong, is the Docker file is more like a recipe that you can create things yourself, whereas I can upload a full image that you could download and run without building yourself.
Yes.
So that's what I'm saying is I could cook the books in the image I create, upload the image with malicious things in it, pretending to be legitimate. Somebody downloads it, oh, hey, a new free version of Candyland. Yes, please. And it's really a Trojanized version.
Yep. So that is one of the concerns about grabbing just random images that aren't part of the official images that are like verified and validated and all that stuff. Like, for example, the Apache image here, I'm trusting that Bitnami, which was the user that uploaded this, that VMware isn't including any special things that I wouldn't want them to in their container.
Right.
So where a lot of that comes into play here, if we grab one of these really low down, so okay, Apache was a horrible example because they apparently have been rather prolific, but let's go Nginx. I can't type to save my life tonight, but like say, so Nginx here, if a bunch of these are trusted, but say like this Glue Federation Nginx, I'm very much trusting that they're not up to any bad stuff. Or like even this, a big call out here is the last time this image with Nginx was updated was 2 years ago. Well, there's been a lot of vulnerabilities and a lot of bad things have happened in 2 years that have been patched. You don't want to be using this container.
And that
And
gets
as you can see, only 40 people have actually pulled that container in the, I think. Oh, that's a per day or a per range sort of thing. There's been 10K people who've pulled it. But yeah, so anyway, though, that's one of those things where know your containers and know what you're building off of. If you're using like the base images like Ubuntu's latest or a up-to-date version of Ubuntu or CentOS or Debian or one of those as what you're building off of, great. If you're using one of those actual projects that are being maintained, so like Nginx, if you're actually using the official build of Nginx, as you can see, they updated it last 7 days ago. Those are the containers you want to be using, not necessarily Bob's best version of Candyland.
Right. But I would assume that if you downloaded Bob's Best Candyland and you did an inspect, as long as it wasn't squashed, and even if it had malicious copycat IDs, that you would actually be able to use that as a recipe and have it pull down the real things and rebuild it with
Yes.
non-malicious copies.
Yes, you should be relatively okay with that. With a bunch of hand waving that, yeah, you should never trust anyone 100%.
Right.
But what can I say? I'm paranoid.
Show me a gray beard that isn't.
Yeah, exactly. But yeah, like here you can pop into the Debian mainline Nginx, and you can see how they go about installing it, which they're putting a bunch of ampersands here. Basically, they're doing a whole bunch of stuff in one run command, which means that all of that falls into one layer, which is nice.
I wonder why. So what we did in a recent Dockerfile was we actually created a script and we copied the script in and ran it, and it still seemed, even though that script had a ton of commands inside, I think it was still one layer. And
Yes.
it's nice because then you don't have to do all this and nonsense with all this, like you just write a regular bash script, you know? So I wonder why
Yep.
they don't, I wonder why that's not more popular. I guess it's just another file to lug around, I guess.
Yeah, so that's the reason
No.
is that your script that is building stuff actually ends up being lugged around. And the nicety here is that you could execute that script and then remove it as the last step, and that would get rid of your script. Essentially, would be
Auditability and visibility into what is purportedly done.
yeah.
Going out of your way to make your image appear to be more trustworthy.
But I too will admit some of my stuff that isn't for public consumption, uh, internal use sort of stuff. Yeah, I've totally done that where I just lob a do.sh script in and execute it.
You know, the best is in GitLab config files. I don't know if you mess with GitLab at all, but I've seen so many GitLab CI.yaml files where people are putting bash for loops inside of the YAML, and it's just the worst. I'm like, please just make a separate file and then just call that one, please, please.
Yeah. Let's see. Are there other questions or things that you want to see? The last one that I haven't shown off yet is the how to do sort of that multi-stage build to do where you build your hello world and then you copy it across from one container to another.
But if you can squash, there's no reason to do that unless you want a different base, I guess. I guess having a different base would be the reason to do that. One
Well,
base
I
to
can
build
see-
and one base to
If you have what his demo being built is relatively simple, but think about something much larger like OpenSSL or OpenSSH that has a full test suite and a whole bunch of stuff, and you end up with just a much smaller distribution directory. So you could have all that cruft in a build container and then copy just the pieces you want into your shipping container.
The other benefit is that your shipping container doesn't need to have any of the build tools. So to be able to build your Rust container, or to be all of the stuff included if you're building a C++ sort of thing. You don't need to install all that stuff into the shipping container. You install it into the build container. If that makes sense.
Yeah, and I guess what that just it's almost like a dev container at that point, right? Because it just basically keeps you from having to have that stuff installed on your local machine, your workstation.
Correct. Like
So-
say, for example, if I was building this on a ephemeral build server and wanted to make sure that all the tooling was installed, that would be one way that you could sort of get around that. So as an example here, let's CD our way back out a little bit. So let's go ahead and as we scroll up just a little bit, let's go ahead and mount let's call it BLD instead of, and this could be Rust latest. And go fast internet. And I totally should have done this while we were waiting. Sorry about that.
Chalk it up to the demo gods.
Oh, I know why, because before I was using Bullseye Slim instead of latest. So it's a different container. Okay, so now it's doing those image source checking, and there we go. And so then let's go ahead and mount. And so then our copy command. Back up. Copy, and let's just go ahead and copy everything to in. Okay, so we went ahead and copied it in, and then let's run the command. Run. We want to set config enter and the app. There we go, and then we'll do run. Rum is later after I get off the call here. And let's do build. And there you can see it got copied. And then let's go ahead and there we go. And now we do a copy from build. It will be app. What is it? Sorry here. App target and then debug. And I'll get this right at some point before the end of the night. There we go. If at first you don't succeed, try again. So we've gone ahead and copied it over. So our directions again are Buildah copy from the build container to our working container, and we're copying this file and copying it to hello world. And then from there, we'll be able to do the Buildah commit container, and let's call it test latest. And there you can see we've already we committed it, and then we just go ahead and do a podman run of test. And of course, we didn't make it executable, so here we are. We just landed in the root directory. And as you can see, it worked.
Do a long listing, please. So it is executable.
Yep.
And // is really about pathing, not executing things that are not executable.
Yeah, just to prove that, minus X. Yep, you are correct. I stand corrected, and yeah.
For giggles, try /space hello world. Okay.
The one thing we can look at here is, I guess it's not in this, but we can do, just to show you what's happening here. And as you can see with the file, it's describing what's going on here. And the big call out here is that it's dynamically linked, and it's using the LD linker that's in lib64. And if we look at,
I would be very curious if you went back into the container. I was reading an article the other day that indicated you might be able to put the path to lib64 LD Linux, the interpreter space, the executable, and run it that way.
okay, so yeah, we'll try that here in 1 second. But the thing to call out here is the fact that the muscle target that we built, if you look at the output, you can see that it was statically linked, and that way you don't need to have all that other stuff bundled along. But let's just go ahead and give it a try. Long as we're trying to break things, I am all for breaking things. So you were talking.
Opportunity.
Yeah, I mean, worst case, there's nothing really critical on this machine. lib64 LD Linux.
Okay. And it was the context I read that in was dynamically linked, and that's a static binary. So
So that particular one that I copied across is a dynamically linked
okay.
file. So let's just go ahead and make it back .x again and try that again just to see what happens. Yeah, and
that is one thing that I have. One of my biggest problems with containers is the environments I've been in, most of them where containers are used, they are either built or downloaded once and used for years at a time. And nothing in them is updated. They're never replaced. So they are a snapshot in time while the host that they run on is constantly updated. And then people are flabbergasted about, well, how did I have a 4-year-old vulnerability? Was it in a container created, downloaded more than 4 years ago? Yeah. That's how.
And a lot of places have rules that if your container hasn't been built in so many days, they either auto trigger to rebuild it and have you must restart your containers every so many days or whatever. And that's the one way around it, is that your containers and your services shouldn't be running for years at a time without restarting and updating. But of course, that's one of those do as I say, not as I do sort of things, because I know I'm just as guilty of some of my own pets that shouldn't be pets.
Well, Podman actually has some built-in stuff to do well, I haven't used it myself, but I've read about Podman having some built-in stuff where if you're running your Podman containers as systemd services, it can automatically update them on some kind of schedule, which is pretty cool.
Yep, and with that, and that's a whole nother talk, which is a very cool talk, but is probably out of scope for tonight. I'm willing to imagine. I'm willing to bet that people at some point want to go to bed here, but that using Podman and systemd to run stuff as services on your machine, it's really cool, and I'm really excited by it. I need to actually use it more than I actually do, just because you might as well use systemd, even though it touches off somewhat of a holy war if you say that you like it.
Speaking of Holy War, you're talking about going to bed, but nobody can sleep until you and James have it out about Rust versus Go. I want to hear it.
I don't understand async Rust, so that's what I've got against it. It's a failing on my part.
That's completely a fair thing. Async anything is really one of those paradigm shifts that it's hard to wrap your mind around until it isn't. It's the same thing as like model view controller programming. It messed with me for quite a long while till it didn't. But to wrap up here with the rest of my slide deck, just to hammer home the if I can get back to it. Okay, here we go. Hitting share. And okay, here we are back to the slide deck. Basically, just hammering home that Buildah's single purpose. It does one thing, it does it well. It doesn't do all of the other stuff, and it's compatible and it's great. Big issues and concerns, just sort of like how I believe somebody had commented about how they find edges in Podman all the time. There are definitely edge cases, and then also the command line syntax, as you can see, it is a little bit schizophrenic, and it really definitely is the road less traveled. So there's less documentation, less really cool stuff there. But it does help that you can definitely scriptify everything rather than having one magic file. And yeah, I think we've already beat the dead horse here with where we've been. I think things will only continue to improve, and having a little bit of diversity in the space so that no one company owns everything is always a great thing. And then, of course, the standard default questions, looking at the comments here, just seeing, heckling on, Go and, Arch vendor OS, and then library, and then of course Rust C, you can fight a bit. Whatever. I don't pretend to actually be a very good Rust programmer. I still am a firm lover of C++ and C#. Now that that's an open source thing, but that again touches off a whole nother holy war.
Every time I look at C#, they have a new way to create objects, and I just get confused. Hey,
Yeah.
isn't there a way with, is it Buildah or Podman where you can like literally exec into the container, make a change, and then like commit that change? Do you know about that?
Yes, that is Buildah, that you can go ahead and do that. And basically you can do it either as with that run command that I was doing, or I believe it's just exec. But we can totally quick jump back over there and go ahead and try that, because I mean, I'll try anything once. Let's go ahead and jump in there. Share. Would help if I click right. Okay, here we are. So let's go ahead and exit. And let's try build a XCC container. Let's see what happens here. Okay, so looking here, there should be some sort of command here. Config containers, copy from images, inspect, log in, log out. That would be how you log on to your container registry if you have a username to push stuff. Manifest, you can actually literally edit the manifest itself.
Was it run? Or
So run will run the command inside of the container. I mean, that's very similar to how Docker runs.
yeah, didn't you run and give it sh?
You know, let's try it.
And
So it looks like there's a podman commit command that takes a -- change, and the -- change takes either command, entry point, env, etc., etc. So that might
Yeah.
be. So it might be an argument on the commit command.
Okay, so if we do that, let's go and do commit, and we were doing $sign CTR, and okay, and then let's just run it. And there you can see that foo and bar were there. So yeah, go ahead and do the run and run space sh, because we don't have bash in this container. And yeah, it works just fine. Because if we echo or cat, there you can see the stuff that I added.
Wow, that's pretty cool.
Yeah, I didn't even realize you could do that. That's kind of cool.
And after you exit the container, I'd like you to run another command. Curious of something.
Yeah, so after I exited the container here, the other command that I ran was buildah commit container. So I was committing the changes to this
Right.
test image.
Right. No, I'm saying after I believe you're in the container that you
Yes.
just, after you exit this one, I have a command for you.
Yep.
Type mount, please. Okay, so yeah, there's a whole bunch of what I think are ugly mounts right now.
Yep, and part of that is I did not unmount stuff. So if you do it just cleaned up the build mount at least.
Right, and your container CTR is still mounted, correct?
Correct. Yeah, because we were doing other shenanigans with it, and I didn't want to have to remount it. Well, I do have to say thank you though, guys, because like all good presentations, the presenter has learned a few things too while we were playing with this together.
Darn it, we haven't heckled you properly then.
That's okay. Like most lugs, it's a pretty friendly room, really, or a set of rooms. So that was the big stuff that I had to show. Any other questions or thoughts? We can go back to what was was it Grant that was having issues, or
No, somebody
Sam?
else was talking about installing, I believe it was Sam talking about Docker on Windows.
Yes, I'm seeing that here. Sam, if you're still around,
He's still on.
Yeah, he's still there.
Well, his client's still signed in.
okay, hearing nothing and seeing no comments from him, I'm assuming he's stepped away from the computer. However, if he wants to, okay, but yeah, if he wants to reach out to me, I am on both social medias, on Twitter as A Denner, or if you want to reach me via email, it's just denner@gmail. To Lee's question, what happens with the Docker Compose project on Podman and Buildah? Docker Compose is actually just a set of scripts that sort of wrap around some nice to haves inside of Docker. You can get away with, yes, I understand the response of cussing. When I looked at the packages on the Debian based world, There is a compatible, and actually with most things there is a Podman compatibility layer that basically essentially just aliases Podman to the command Docker. So whenever you hear and see people send, yeah, okay, that's a good point, James. It's been a while since I've looked at it. I stand
Yeah.
corrected.
Um,
But
And they did that specifically so that Podman people, I'm not, you can't convince me. I think they did that just so Podman couldn't use it, because for the longest time when Docker Compose was a separate command, if you had Podman installed, it would somewhat just work. You know, it wasn't perfect, obviously. But now that it's built into the actual Docker command, if you don't have Docker installed, you can't run it. And so I think they did that specifically on purpose to try to make more people have Docker installed as opposed to Podman or any alternatives. There is
Just-
still a Docker -compose command out there that you can run, and for
Mhm.
now it still like works a little bit, but it's, you know, I think it's only a matter of time.
yeah, I'm sure they're going to break it as well. But I do know there's a package that you can install in Ubuntu and Debian that installs that Docker-compose script. And then with the Docker compatibility layer, it still does work. I imagine what's going to end up happening is that Podman's going to build it in to keep their compatibility-ness. But speaking of reasons why people are angry at Docker, it's stuff like that. But Lee, I do feel your pain. One solution is to just say, fine, I'm not going to use Docker Compose at all, and move to something like Kubernetes instead, where you can leverage similar sort of ideas in namespaces and sort of stuff like that.
Yeah, and that's how I feel about all of Podman, to be honest. For stuff that I'm building, like if I'm creating the container, that's great. Like it works fine. But as soon as I want to, if I come across something on GitHub and I just want to try it out, it's going to be built using Docker. It's going to have Docker Compose to like spin it up and try it out. And then they're not going to have built it with Podman in mind. They're never going to have tested it with Podman. And so it's like, you know, 50-50 at that point, whether it's going to work or not, you know? And it's just, I am one of those people who's angry at Docker, but I'm also still using Docker because I've had so many issues so many times with Podman.
I understand completely. And at work, on my daily driver, I must confess, I do have Docker installed instead of Podman. But that's mostly just partially due to inertia, because it was already installed before all the shenanigans happened, and I'm lazy. But I do have several machines here locally in my house that I do personal stuff on that is I've totally drank from the Podman Kool-Aid and run stuff there just because I like to keep my feet in both worlds.
Yeah, and the system D integration is so cool, right? And then if you go like a step further, there's like this quadlets thing where basically you can run the Podman containers as system D units just by dropping like a quadlet file in your home directory or something like that. And that just seems pretty cool too, just like a real super easy way to just run stuff. But so yeah, it's something I want to look into more, and I really, you know, I just hope the compatibility story keeps improving, you know.
And it has improved so much from where it once was, but it still has miles to go. I also like the fact that it has compatibility with Kubernetes as well. And so you can run your YAML files, at least in theory, and it will do pods inside of it versus running the full weight of Kubernetes. Although I do have a K3S instance, which is a whole nother talk again.
All right, anybody else?
Put a bow on it.
Yes. I suggest the bookend, Lee, if you would, then shut her down with recording.
All right, folks, this has been the St. Louis Linux Users Group meeting on August 22nd, 2024, where Andrew Denner has regaled us for 2 hours and something with all things Podman, Docker, structure-wise, and related topics. And if I can find the button,